Hey, AP Chemsters, this is Mrs. Vanderlei again, bringing you Blankwalle 2.7. So we are still in Chapter 2, talking about the atom, and now we're going to go to the periodic table, which kind of gives you some ideas of, some of the properties going on here. So this is the periodic table and the periodic law. So if you don't already have your periodic table out, please get it, and I'll meet you on the next page. So what is the periodic law? Well, some of you might be familiar, like in math class, all right? So if we're looking at a sine curve, does that sound familiar? All right, if I were to draw a sine wave, wouldn't that be a sine? That's pretty good, actually. That's a sine wave. And then what happens next? Doesn't it repeat? And we call each of these, here's one period of a sine wave, here's another period of a sine wave, and it's a repeating pattern. So a periodic law is a repeating pattern. So it says when the elements are arranged according to increasing mass, certain sets of properties recur what periodically? They repeat. That's the whole idea. They recur, they repeat periodically. So what can we say? Lithium and sodium and potassium, they're all in the blues. They all have very, very similar properties. We call them, the alkali metals that are extremely reactive. The ones in the purple are beryllium, magnesium, and calcium. We notice there's something very similar about their properties. And notice when they're put on the periodic table, this is how they're arranged. It's very interesting that your book puts them together like this because one of the first efforts to put the elements in a certain pattern worked that way, okay? And unfortunately, the man that was trying to work through this got stuck, all right, at calcium. So once he hit calcium, he's like, I can't make this pattern work. It wasn't until 1869 when Mendeleev realized that there was this gap in between the calcium family and the boron family that things seem to go together a little bit better. So, but that's how these early periodic tables are put together, is by these repeating properties. So these all have similar properties. These have similar properties. All of these columns had similar properties. That's the periodic law. So we do have major divisions in the periodic table. A very important one is this staircase. If you recall from your first year chemistry class, that separates your metals over here to your nonmetals. Those along the way are your metalloids. Make sure you know that hydrogen, even though it's over here on the left, truly is a nonmetal. Okay. So what we need to do, first I was looking at the periodic table. They are increased by atomic number of protons. And I told you in a prior video that Henry Moseley in like 1914, 1915 was the man who discovered the proton and realized that every element had a different number of protons. And I also said that this was reaffirming Mendeleev's periodic table, because if you look, the atomic masses don't always increase going across. All right, there's a couple flips in there. And Mendeleev still said, no, I think my periodic table is correct, even though there's some inversions with the atomic masses because their properties belong in these families. So once Moseley came along and says, okay, the periodic table, as Mendeleev put it, is correct based on increasing number of protons. What else does Moseley do for this? How do I know there isn't a gap, let's say, between mercury and thallium? All right, how do I know there isn't a missing element we just haven't discovered yet? It's because of the number of protons. And until Moseley did that, they weren't sure if there were more gaps, okay? Mendeleev had a huge gap in his periodic table, and that's your noble gases right here. Why do you think Mendeleev did not put noble gases in his periodic table? Because they weren't even discovered yet. All right, so how are we positive that there aren't some unknown elements we haven't discovered somewhere within this periodic table? It's because of the protons. Each element has one more proton than the next. We have something called groups or families. There's 18 vertical columns, have similar physical and chemical properties based on why? The similar electron configuration. We'll talk about that later on in the year. What the heck's an electron configuration? There are 7 horizontal rows. You notice that they are marked right here. So I have showing here periods 4, 5, 6, 7. What about your lanthanides and your actinides? They follow. Look right here. Lanthanum is element number 57. Cerium is element number 58. and then they go through this whole thing, and then here is element number 72. So it's like having a little accordion fold and sticking these elements in between the LA and the HF and the AC and the RF. Okay. I can't wait for element 119 to actually be discovered, because look right here, we have this whole thing is filled up right now. So the next element to be discovered will be this right here, and that will start a very brand new period, period 8. That's exciting. Okay, what else do we, whoops, sorry about that. What else do we know? We know that we progress from metallic character to the non-metallic character. What does it mean to be a metal? Well, what did we just learn in the last section? What do metals do? Metals lose electrons. All right, so the ones that most readily lose electrons are your most metallic elements, really. Elements that most readily do not accept or lose electrons are your most non-metallic. What do? They end up gaining until you hit your noble gases. So it says on the periodic table, can you label these areas? So group 1, can you label up here, right here, these are your alkali metals. Don't include hydrogen though. Alkali is an Arabic word, which means basic, which means non-acidic basic. All right, that's where the alkali word comes from. Typically, any word that begins with AL is going to be an Arabic word, like alchemy is previously an Arabic word. It means from the black earth. Here's your alkaline earth metals. Again, somewhat basic metals is really what they're saying. And then over here, your noble gases as group 18, and group 17 are your halogens. So if you can label those, that would be fabulous. We have a few other things that we need to label. Your transition metals. Well, where are your transition metals? Do you remember that from your first year chemistry class? Your transition metals are here kind of in the middle. So let me scroll up here. These are your transition. You may or may not remember, this is called your D block. So going from element 21 to the 30, from scandium to zinc, these are your transition metals right here. What else can we label? We can label your rare earth metals. Those are your down here metals. So both of these period 6, period 7 at the bottom are your rare earths. What else is your metalloids? Metalloids are on the staircase, all right? So here, where I should put these. Your boron, silicon, germanium. So I'm going to do this. Ready? There we go. And these are your metalloids. How's that? And then finally, your nonmetals. They are on the very right-hand side of your periodic table. And here we go, scroll up, there we go. And these are your ones in this period. This picture is the blue. So your carbon all the way over down to 118 will be a non-metal. And don't forget, hydrogen is also a non-metal. Okay, so you got those all labeled? Excellent. All right, so from your prior knowledge, list the properties of each. So pause this, jot down what you know about metals, jot down what you know about nonmetals, and see how you do. So pause this, and I'll be right back. How'd you do? So metals, I think, I just like picture aluminum in my head. How's that? It's shiny, it's silvery color. There's only 2 metals that are not silvery color. It's gold and copper. So, maybe there's an element out there you know nothing about. I don't know. How about hafnium? How's that? Do you know anything about hafnium? Have you ever seen hafnium? Chances are a good accident you don't, or you haven't, but you still know it's going to be shiny. It's going to be silver color. Malleable, what does that mean? It's bendable, it's flexible. You smack with a hammer and it won't break. And it conducts. Well, what does it conduct? It conducts electricity and it conducts heat, all right? Non-metals are pretty much the exact opposite. Non-metals are not shiny. There's not a single shiny non-metal. They're dull. As far as the color, a lot of your gases are colorless. Some of them are colorful, though, so your fluorine and your chlorine do have colors. But your noble gases are colorless. Your hydrogen is colorless. Other things have color, like carbon is black, sulfur is yellow, phosphorus can be red. So you have other colors as well. Remember I told you iodine is the Greek for iodos, which means violet in color. Bromine is red. So what's the key thing? None of them are silver color. So if you look at it and it's not silver and it's not copper or gold, it's going to be your non-metal. They're brittle. If you smack with a hammer, what if you were to smack a charcoal briquette? Will it shatter? Yes, it will. So it's brittle. And then most do not conduct. Okay. We can talk about metalloids, and metalloids will be a combination of both. I think of silicon. I don't know if you remember silicon from your first year chemistry class. We saw that it was shiny. It was a kind of a dark silver color, but as soon as we smacked it with a hammer, bam, it shattered into 1,000 little pieces. All right, so that would be a property of silver and shiny of a metal, but it's brittle like a non-metal. So your metalloids can have properties of both. What I'd like you to do now is, do you have your periodic table? You need it. Will you fill out this problem number 14? Just label them as noble gases, halogens, just to get recognizing these different topics. So pause this, fill it out, and see how you do. So how'd you do? Hopefully you got them right, okay? The next, ions in the periodic table. Okay, so we can predict charges based on where they are on the periodic table. So main groups, which is your group 1 and group 2, tend to lose electrons at the same number of electrons as the nearest noble gas. What does that mean? Lithium, remember lithium, help, I lost an electron, are you sure I'm positive? Well, when lithium lost an electron, it now has only 2 electrons in its outer shell, just like helium does. All right. Hey, when beryllium lost 2 electrons, are you sure? I'm positive too. It starts off with 4, loses 2. It now has 2 electrons, like neon, a noble gas. So how many do you think sodium is going to lose? Sodium starts out with 11. It's going to lose 1. It gives its 10 electrons, just like neon. So they're going to lose the same number of electrons as the nearest noble gas. Your nonmetals, group 13 through 18. Now notice not every element in group 13 is a metal, all right, or is a nonmetal. Even boron's a metalloid. So start with carbon anyway. Will tend to gain electrons, the same number of electrons as the nearest gas. So if I were to look at fluorine over here, it will gain 1 electron, just like neon. Chlorine will gain 1. Okay, so we're going to do problem number 16 now, where it says predict the charges of aluminum, sulfur, nitrogen, rubidium. Why don't you pause this and you come up with your charges based on where these elements are on the periodic table. Remember, your metals lose electrons, become positive, just like lithium did, and your nonmetals are going to gain to become negative. So pause this, see how you did. All right, so how did you do? Did you get aluminum's +3? How did I know that? Aluminum's going to lose electrons, become like its noble gas. So if it has 13 electrons to start with, it's going to lose 3 to become like neon, the noble gas. Sulfur is going to gain 2 to become like its nearest noble gas. So if it starts out with 16 electrons, it's going to add 2 to become like argon. Nitrogen is going to add 3 to be like neon, and rubidium over here is going to lose 1 to be like krypton. So hopefully that brings back some memories from your first year chemistry class. This is the end of 2.7. So like I always say, don't wait to be great. Bye.